Bismillahirrahmanirrahim. Assalamu alaikum. Dear student, today I am going to describe class 12, chapter number 11, and the name of the chapter is electrostatics. So, today topic is electric potential. Students, this is a very important topic in your second year physics. Before earlier this topic, we find the electric intensity uh, between two oppositely charged plates. So, continuing from that topic, consider two oppositely charged plates. One name is plate A, which is a positively charged plate, and the other is B plate, and B have a negative charge. So we can say that plate A is at higher potential and plate B at lower potential. So let a charge Q naught, which is positively test charge, or you can say this is a positively charged Q naught. This charge is placed between two oppositely charged parallel plates. So this charge Q naught experience a force in this electric field. You know, electric field lines are originate from positive and end on negative. So this charge Q naught moves in the direction of electric field lines. So we can say that there will be no work done if the charge is allowed to move freely in electric field lines. So this charge will move from plate A to plate B with the force Q naught E. This is the electrostatic force, and we describe this formula in electric field intensity. So we define in that topic electric field intensity is the force per unit test charge. So this charge particle move freely from plate A to plate B and acquire kinetic energy. So on the other hand, if an external force is required to move the charge against electric field, it means the spacing between these two plates, let's suppose this is the describing the space having D. These two plates at a distance of D. If I apply a force, this is electric force, and this will be an external force. If we apply an external force which is equal to the electrostatic force but opposite in the magnitude, so this force produced a work done. So I can write a work done, but this work will be done from in opposite direction of the electric field. It means this is the work done from B to A. So we can write this is the work done from B to A. This work will be done on a charge Q naught. So I can write this work done on a charge, test charge, while carrying from low potential to higher potential. So this is called the potential difference, and the potential difference is denoted by delta V. It's mean if we can say that the potential at point A is VA, and the potential energy at this point is UA at point A, at plate A, and the potential at B is VB, and the potential energy at this point is VUB. So in earlier classes in 9th or 10th class, you can study the work done is equal to, or work done from B to A. You can write in earlier classes, this is the change in internal energy, or this is the change in potential energy, because this charge Q change its position. So due to the change in position, we can write here work in the form of potential energy will be stored. So the only work will be done if we apply an external force, and this force is equal to the electric force Fe, or Coulombic force. But these two forces are opposite in nature. So we can define the potential difference, the work done on a unit charge while carrying from low potential to higher potential when this charge will be kept at equilibrium. So this is called the potential difference. And if I can write this equation 1 and this is equation 2. So this is the formula for potential energy. We can rewrite this equation 2, but first we solve equation 1. So equation 1 is delta U is equal to work done from B to A. I can write this in the form of UA and UB. It's mean this is the difference. So the difference between these two potential is delta U. So we can write this equation 1 as in the form of UA minus UB is equal to work done from B to A. We can say this is equation number 3. So UA and UB represent the potential energies at point A and at point B. So if this charge is released from A, it will move from A to B and will gain an equivalent amount of kinetic energy. So this charge will move with some velocity, some speed. So when it's moved from A to B, it's acquired some kinetic energy. So the potential difference between 2 points is the work done in moving a unit positive charge from one point to another, keeping the charge in electrostatic equilibrium. It's mean we can say that the work done, the equation 2 will becomes the work done which is from B to A on a charge. This implies that this is equal to delta U over Q naught. These both terms are equal, and if we rewrite these equations, I can say that if this equation it becomes equal to this equation, so we can say that these all are equal to the potential difference. So I can write this again, delta U over Q naught. This is the potential energy, change in potential energy. This is equal to UA minus UB over Q naught. And we can say that this term, I just replace delta U, which is the change in potential energy, to UA minus UB, which is the difference between these two potential energy that point are at plate A and at plate B, and these are equal to, I can write this change in VA minus VB. This is the potential at plate A, and this is the potential at plate B. I can say this is the higher potential, so VA is the higher potential and VB is the lower potential. So in all, you can write this as delta V. So it's mean that we can write work done in the form of potential energy, or we can say that when the charge move freely from plate A to plate B, it's acquired kinetic energy. So we can write all these in this standard form. So we can say that here VA is our potential at higher potential and VB is at lower potential. So they defining different equation. I can start from here. At UA, we can write this is Q naught VA, and at UB we can say Q naught VB. So from here we can write this equation delta U is equal to Q naught into delta. From these above equation, we can say that we can write this in general form. This is the change if we use potential energy at plate A. So for that value we can use the potential value of the potential of that plate. If we using the plate B the potential energy, so we can use only potential for plate B. So for general change in potential, we can use the change in potential also. This is the potential energy and this is the potential. So delta V is the potential difference, and I defined this earlier. Work done on a charged particle while carrying from low potential to higher potential, and this is called the work done. And at when we apply some condition for electrostatic equilibrium, so this we can call that this is the change in potential difference. So if we can write delta V, this is called potential difference. The unit of potential difference is volt. So if we can write 1 volt is equal to, so from this equation we divide potential energy by Q naught. So the value of potential energy is joule, and the unit of charge is coulomb. So 1 volt is equal to joule per coulomb. So joule per coulomb is called volt. So volt is the unit for potential difference. If in exam point of view, the question will be given in the form of define volt. In mostly in short question, they can say that define 1 volt. So if I can define this, so 1 volt is the potential difference between 2 points in an electric field. If 1 joule of work is done in moving 1 coulomb of charge, 1 joule of work will be done on moving 1 coulomb of charge from low potential to higher potential or from one plate to another. This is called 1 volt potential difference. So 1 volt is the higher potential, or we can say that we use multiple units for this, like we can write the 1 millivolt, and 1 millivolt is equal to 10 raised power minus 3 volt, and we also use 1 microvolt, and this is also we can say that this is a 10 raised power minus 6 volt. 1 kilovolt, and 1 kilovolt is equal to 10 raised power 3 volts. We use the some multiples units, other units for volt, and we can say 2 other units is 1 megavolt, that is equal to 10 raised power minus 6. 1 gigavolt, that is equal to 10 raised power 9 volt. So these are the other units, multiple units of potential difference, and in numerical values we can write these values. So I can just write a general formula for potential, that is potential difference, that is V, and V is equal to the work done on a charge while carrying from low potential or from one plate to another charged plate. So this is called the potential. So this electric potential topic is for class 12, but this is also in the class 10th topic. So class 10 students, you can note this topic as well for yourself, because in your chapter number 13, in chapter 13, and the name of the chapter is same, electrostatic. So this whole topic is also for class 10th. So students, you note down this topic, and also this is the whole topic is for your syllabus included. Stop. Students, now I am proceeding towards our another topic, which is the potential due to a point charge. Like Earth's gravitational field, every charge has electric field which theoretically expands to infinity. Like if I have a positive point charge, this is a positive point charge, so its electric field will expand to infinity. This is infinity, and you know the from positive point charge, the electric field lines is radially outward. If a test charge is bring from infinity to that point, and we can find its potential at point A and at point B. So point A and point B are two points, or you can say these are, like in previous topic we can find the two oppositely charged plates. So these are the 2 points. If we can say we divided this interval, like this is another point, and this is another point, and this is another point. This is R1, this is R2, this is R3. Basically, if I can say that the total distance between A and B is R. If we divided these intervals, like if I can say that this is the first patch and this is R1, the distance between these C point, and this is a D point, the distance between C and D is R2, and this is D, and this is another point E, the distance between these 2 points is R3. So we can divide this patch by small intervals. So we can say that if a test charge is placed at infinity, and the force on it due to this positive Q charge is 0, because the distance is too much. As the test charge is at infinity and moves towards positive Q, hence with the test charge is at point A, at this position, when is the Q test charge is at infinity, so the plus Q charge does not exert any force. And when we move this towards the Q charge, so at point A, some force, or you can say that some electric potential energy they have. So for that we can say that the electric intensity for this q charge is equal to, we can say, we can find this in start topic in this chapter. So that is kq over r square in the direction of r. R is a unit vector. So now plus q is at higher potential, is at higher potential, and that is infinity, that is lower potential. So in order to keep this E constant, the test charges move through the infinitesimally small displacement, and that is equal to, we can say that the distance between any points or r1, that is equal to, we can say, if for this small interval, we can say this is very small distance, so we can replace this r1 by delta r. Delta r is so small, if delta r as compared to r1, this is a so small value r1, r is less than r1 as well as r2 and r3, or r is greater than r1, r2 and r3. So if we bring this charge, this test charge towards plus q, so some work will be done. So the change of work done is equal to, I can write this is q, and that is equal to E dot delta R. So you can say that where these equations come from. These equations come from the topic, you can say that the work W is equal to F dot D. So here the displacement is delta R, so we can write this in the terms of delta R. This is the rough work. You can write the rough. Force. From here, this is electrostatic force, and electrostatic force is equal to Q into E. You define this electric force, or you define the electric intensity, which is equal to force per unit charge. So from that equation, we can say that the force is Q into. So the work will be done in the form of QE into delta R. So I use this equation here. So you can note down that this Q is moving against the electric field, like Q is in towards the positive Q and the electric field line is away from. So these are anti-parallel, so I can use a negative sign here. But you know that if we remove this dot product, it's a scalar product, so if we remove this, we use cos theta, and here theta will be, because Q and E, this is E, electric field line or electric intensity, both are anti-parallel and having, it means they having 180 degree. So we can put here 180, cos 180. So you know that cos 180 is minus 1. So this minus and this minus cancel out each other, and we get work done is QE into delta R. You know that cos 180 is equal to minus 1. So this minus and this minus cancel out, minus minus plus. So you can write this is work done plus QE into delta R. You can say this negative sign shows that E and delta are in opposite direction. So this is our general formula, and we can say this is formula A or equation A. Now we have the value of E. So in this value, I can write this again. We can say that E is equal to K Q over R square, and that is in the direction of R. So you can see from this diagram, here we have 1 over R square. So that in particular case, here we can write this R1 and R2. It's mean here for this particular point, when we are moving towards this to that point, so it will becomes RA. This is the first point, and the second one is R1. So this R square, we can write this R square in the form of RAR1. So from equation, if we put the values of E and delta R, so what will be the delta R? What will be the value of delta R? So delta R is equal to RA minus R1. This is an equation 1. So we can put the value of E, delta R in equation A. So equation A will become, and this is the work done from R1 to, we can say that the work done from RA to R1. In book they will write from R1, so you can write R1 because we are moving toward this point, so so we follow the book. So the work done is equal to capital Q over 4 pi epsilon naught, and we put here 1 over the value of R square, that is equal to RA R1, and here we use delta R. So for delta R we put RA minus R1, and this is the direction of R. So we can use this at earlier. So this is the work done from R1 to RA. If we write this equation, we just break this equation from that point. So we can have equation like, if the work done from R1 to RA, that is equal to Q small q divided by 4 pi epsilon naught, and that is equal to, if we just solve that, so we have RA over RA R1 minus R1. We split this equation, so we can write as well as, so R1 cancels R1, RA cancels RA. So I can write here again, we can just left with, we just have here, after that solution, we just have R1 minus 1 over RA. So this is our equation 2. I can rub these points again. So this is a long calculations, so you focus on these calculations. These are very important, and this is a long question for your course. So if we move from this R1 to R2 point, so we can write the equation R1 to R2. We will just solve the general formula, so that will be R1 minus 1 over R2. So from equation, the book have some mistakes in these points, and the mistakes will be the charge starting at point A. So this is the point second point, and this is the point 2, which is R2, and let's suppose this is the nth term. So the charge is moving from A to B. So the work will here is in the form of, we can say that this is in the form of A to 1, A to 1, and from here 1 to 2, and from that the next one will be Rn to Rb, means this is the distance, we can say that this is Rb. So the last work will be Rn. N is any nth point or any infinitesimal small patch. So this is Rb. So we can write 4 pi epsilon naught. So you can write this in your also in your books. So we can say that this will be 1 over R and minus 1 over RB. So we add up all these works done. So we get the total work, which is equal to from A to B. I sum up all these questions. So we get the answer of these all. Addition of these all is equal to, I just summarize and also explain in detail in class. That will equal to 1 over RB minus 1 over RA. This is in general. So if we can say that RA, this is at infinity point, means this is the close to the point A, and we can say this is at infinity. So 1 over infinity, that will becomes equal to 0. So we get a formula for work done, which is equal to delta W, and this is only having 1 over RB. So we can say that this is the distance, or this is the distance at point B, which is nearly equal to that point in which we can come to the infinity. So we can replace this by potential. So we can write this as a potential. So the other term will be QQ over 4 pi epsilon naught. So in general we just write 1 over R. So this is the formula. This is the formula for potential at any distance or due to any point. So if you compare this with potential, we can say that for just compare with W over Q, and I can write this W over Q, which is equal to V. This is also the work done per unit charge. So this is the important topic, potential due to a point charge. In this we can divided a whole path from A to B in small patches, and from that we can include we find a work done. So this is the total work or potential due to a potential difference. So in next topic we can also find the field and potential gradient, which is also related to this point. So students, keep watching, and for any query just ask questions in YouTube or in Messenger or WhatsApp anywhere. So thank you to all of you.